Greetings. In today's lecture, we'll dealing about analysis of trusses. In this chapter, we'll cover analysis of determinate and indeterminate truss using the concept of strain energy, finding out the deflection of a truss, then finding out the stresses on the in the truss member due to yielding of the support or temperature changes. To begin here with, let us start with a question: what is a truss? A truss is an assemblage of uniform bars or members joined together at their ends by riveting or bolting or welding that creates a rigid structure to support a load. The trusses are generally made with a members which are of uniform cross sections. They may be either a bar or a predefined shape member like circular section, angle sections, channel section, eye section. Depending upon the loads which are applied, the member requirement will change. We can have for light load structure, we can have timber trusses also. When the loads are very heavy, then we are going to use the mild steel elements. Okay, the function of this truss is to transfer the load. The members of the truss which are generally enclosing a area, they are connected with the secure end supports so as to withstand the load which are coming on it. The very first function is that the truss should be stable against whatever the loading which we have applied along its geometry, and the connections are so prepared that they are capable of transferring the load amongst the member and thereby dissipating the total stresses which are coming on the truss. The connections are made with the help of the elements which creates partial rigidity or rigidity towards the structure. For example, if we move from right hand side, we see here there is a welded connection. This connection is said to be a rigid connection where there is a completely seizing of the end, and this connection is made in with such a metal that it possesses the same character as that of a parent element. Thereby, it acts as a very rigid support and a secure support. Again, now if you go towards the middle picture, which is that there is a connection made with a metal pin which has a threading ends here which receives the net, and after clamping it produces a clamping force and thereby secure the connection through the clamping force. Such type of connection is called as a bolted connection. If you go towards the left hand side figure, we see that there is a rivets attached to the connection. The rivets are nothing but the metal pins having one side the buckle head and the second side is being produced by applying force or forging the element, thereby having a clamping action. This end connection assures that whatever the loads which comes on this your trusses is going to uniformly distribute along the members, along the geometry of that truss. Okay, let us find out where we generally find such type of trusses. Such type of trusses are generally used in case of roofing system, where we are going to provide a pitch roof for a large span, and to cover with this large span with the help of flat roofing, it will become a very heavy structure. And to reduce the stresses, what we do, we provide a pitch elements which has a triangular geometry which has various elements performing stress load distribution. Okay, so bottom chord, then we see about the principal rafter, vertical member we called it as a your strut and inclined members. Sometimes horizontal members are used. This combination is used to dissipate the forces which are coming through the member action over the large span. These trusses are being in connections to each other, covering the entire geometry which has to be provided with the shelter, and the roof coverings which are provided over it which will generate the forces. This force will be the dead force or the wind force which are coming on it. Sometimes live load will also come due to the access if you provide along the roof. Okay, these trusses are connected to each other with the help of a horizontal member in a transfer direction, thereby providing the distribution of the force which are coming from roof system towards the panel points, The junctions of its truss elements are called as the panel points, which will receive the loads from the your roofing system. So generally we find roof trusses which are being used as a covering element for the structures or roofing system. The common types of trusses which are being used in industrial shed or practices to cover the roof are track truss, wing truss, house truss. The second application of the trusses is towards the bridges. The load is transmitted by the deck to a series of stringers and then set of floor beams. In case of bridges, the trusses are used to connect large span viaduct portion, or we can say overhead portion, or we can say a crossing over the river, or any other obstruction. We are going to provide a spanning in inverted format. Here the bottom cord will be supporting the deck slab, and this deck slab will be supported by stringers. These stringers are connected at the panel points, and the loads from the deck will be transferred to the stringers to the floor beam, and floor beam to the truss panel element, we can say nodal points. And this nodal point will then transfer the forces to the various within the members, and there will be a distribution of forces, thereby making stability of the structure. These trusses may be used these trusses may be used for bridges. It may be used for covering the cross overheads over the rivers. Sometimes they are used to provide the conduits. Sometimes they are used to prepare a crossing for a pipelines, and many more. The example trusses which are used in bridge structures are Baltimore trusses, Pratt truss, Howe truss. Okay, let us try to classify the different types of trusses. Trusses are basically classified into two heads: planar truss and space truss. When the members are being within a plane, or the member is going to occupy the space which is been defined by a two-dimensional geometry, then I am going to call that as a planar truss. When the members are distributed along the three dimension, preparing a three-dimensional structure, we are going to call it as a space truss. Example are the electric towers. Here, if I want to classify the planar trusses further, the planar trusses are classified as a simple truss, compound truss, complex truss. A simpler geometry defining a simple triangular envelope, thereby creating a skeletal structure, we are going to call it as a simple truss. When we are going to use the compound elements of triangular geometry covering the area, then we are going to call it as a compound truss, where one or two or three triangular groups can be easily identified. When we are going to have a assemblage which will create a certain nature of complexity in itself, defining n number of loops connected to each other by various end connection or end restraints, then I am going to call it as a complex truss. Right hand side figure shows that there are n number of loops which are having the connectivity, defining the loops inside it, but the ends are being secured, at the outer periphery the ends are being shown secured with the help of your pin connection, but the crossing or overlapping element, we are not going to define any hinge here. Thereby it leads to a complex geometry, and it is a little bit cumbersome to find out what are the forces in that particular truss. Such type of truss is called as a complex trusses. Now we'll move towards the basic assumption which are being used for the analysis of a truss. Before that, we'll talk about what type of connections we generally applied in case of a structure. In case of a structure, we provide flexible connection or pinned connection, semi-rigid connection, or we can say rivet or bolted connection, rigid connection, welded connection. This connection plays an important role to transfer the force from the ends to the member. If the flexible connections are there, they will allow the translation and rotation. Thereby, the force distribution will be only along the cross-section area of the member, assuring that the forces are axial forces. Whereas in case of semi-rigid connection, they are going to provide the resistance against the translation or rotation, partial resistance against the translation and rotation, thereby introduce additional stresses which are being developed due to such a restraint. In case of rigid connection, this connection will completely clamp down the translation and rotational degrees of freedom for the structure, thereby introducing the additional stresses over the member. There may be the axial stresses, there may be the shear stress, there may be twisting stresses, or we can say bending stresses developed due to twist, or flexural stresses developed, bending stresses developed due to the flexural forces. Okay. So in case of truss, the very first assumption is that truss members are connected by smooth pins, so as to ensure that the members are subjected to the axial force only. That is the very first assumption. What are the pin connections? Let us have the view over it. The pin connections are made with a cylindrical steel metal pin inserted between a connection, which just form the axis for rotation. It doesn't clamp the moment of the joint. If you see here, the pin is simply inserted between the two elements. This one is an eye end of the member, the second one is the eye end of the connecting plate. Only simple the pin is being inserted, and this pin will allow the rotation of member along its cylindrical axis. If you see the cross section view here, to have conformity that this pin will be secured in the connection, it will not get loosed out or get free removed out, we are going to add a counter locking to this by a pin. This pin will not interfere in the transfer of the force, but it will ensure that this pin will not get moved when the connection is in working. This we can see here, the connection made for actual position of the connection, which is made for a roofing system. Here simply pin is being introduced, which secures that the connection is going to be a flexible one. Now what happens if I provide the smooth pins for the connection here? The stresses produced in the element is called primary stresses. These are stresses which are being introduced due to this type of connection will be said as a primary stresses. The assumption is valid for rivet and bolted connections only. Sometimes we can have the flexibility with reference to the bolted connection. It depends upon what type of clamping force I am going to apply. We have two types of bolted connection here. Very first one is we can say black bolt connection, where we ensure that only the clamping is there and there is no clamping force or resistance developed, like in case of high friction grip bolts. In case of welded connections, members are subjected to light bending moment, producing bending stresses known as secondary stresses. So generally we avoid the welded connection in the analysis, or if we consider, then we are going to provide certain provisions related to the bending stresses and involvement of the bending stresses in the analysis of the forces. Next to that, the members of the trusses are straight members and loads are applied at the joints. Here members are very stressed between the 2 points, and the load carrying capacity depend upon its slenderness. If it has an initial crookedness or slenderness, it will definitely impart on the load carrying capacity of it. Thereby we have to assure that members are straight and the loads are applied at the joints only. Every members of the truss is a two force member. This is a very important one. Two force member means the member of the truss will have dual action here. For example, if I apply a load at a joint here, then let's the load be a gravity load, then there will be action among this triangular geometry. It will try to deform this triangular geometry. Some members will be subjected to the extension and some members will be subjected to the contraction. The members which are subjected to the extension, we are going to say they are going to carry tensile forces. Vice versa, the contracting member will have compressive force developed. This will be either developed by the gravity or certain impact. Okay, So when we say there is a reversal of the force, then they may be subjected to in